My name is Gunda Georg, and I'm the head of the Department of Medicinal Chemistry at the University of Minnesota. And I'm also the director of the Institute for Therapeutics Discovery and Development. We are interested in male contraception, and one of the validated targets for male contraception is the testis-specific bromodomain. Mice that had BRDT, the bromodomain that's testis-specific, knocked out, showed the infertility phenotype. And so that was validation that this could be a potential target for male contraception. And this was further validated by using a bromodomain inhibitor by the name of JQ1. And when mice were treated with this particular compound, they also became infertile. And very importantly, when the drug was discontinued, the fertility returned to normal and they sired normal offspring. And so the problem with this particular compound, while it's quite good to provide and provided a proof of principle, it is not selective enough. It inhibits other proteins that are closely related in structure, and therefore we're looking for new types of inhibitors that are much more selective than those that are known to date. We use all the techniques that we have available here at the University of Minnesota to find what's called new chemical matter. So we're looking for new compounds that maybe will provide the selectivity that has eluded researchers before. And so we use really a lot of modern techniques. We use computational approaches, we use screening approaches, and we have multitude of libraries available here to do that. We have over 300,000 compounds that we can use for testing. We have what's called fragment libraries. We have what's called DNA-encoded libraries. So we use all of those techniques to arrive at new chemical matters. And once that is accomplished, then we use modern medicinal chemistry techniques to optimize those compounds for the intended purpose, in this case to find a selective inhibitor for this testis-specific bromodomain protein. I'm a member of the Epigenetics Consortium, and I participate in the seminar series, so I always make sure that I come to the seminar, that I also suggest speakers for the seminar, and it gives me an opportunity to learn what others are doing here locally, because we also have local speakers, and so then there are opportunities for collaboration within the university as well. I have taken advantage already of this consortium in many ways. First of all, I want to say one of the foremost tasks being in an academic environment, of course, is the education of the next generation of young researchers. And a consortium like this provides a multitude of opportunities for students to, first of all, listen to seminars by leaders in the field, and to also actively collaborate across disciplines within the University of Minnesota. And in my group, we have really taken advantage of that in many ways. And so this type of collaborative work really enhances what an individual group can do, especially if we're all focusing more or less on one theme, which is epigenetics. So when you're in a field like medicinal chemistry, there are many techniques that you have to bring to bear. And no one lab really has all of those techniques. And so we're working, for example, with our colleague Will Pomerantz here from the chemistry department. He has developed a very, very nice technique to identify inhibitor binding through NMR, nuclear magnetic resonance techniques that he calls ProfNMR. So we have been working quite extensively with him. We have co-published, for example. Students in my group have worked with people in his group to learn some techniques or to carry out certain types of experiments, and the other way around. Students from his lab have come to my lab to learn some of the techniques that we are specialized in. The epigenetics program here will stimulate excellence in epigenetic research at the university, because when you bring together different types of groups, different types of techniques, you fertilize each other, you talk to one another, you come up with better ideas for sure. Also, we hope in the future that perhaps we can maybe apply for a center grant to formalize this even more, this consortium, and include also people from other universities potentially, perhaps from Mayo Clinic, because we have this seminar series jointly with Mayo Clinic, so that is sort of our next door neighbor, and that would be a natural that we would also work more closely with them in the future. I think people should recognize that epigenetic research, which is fairly young, really has a great future ahead of it. I would say there are many unsolved questions in epigenetics research, and this is very fertile ground for exciting new research in terms of being medically relevant in different types of disease states.